ಹಲೋ ಫ್ರೆಂಡ್ಸ್, ದಿಸ್ ಈಸ್ ಸ್ವಾತಿ. ಸೊ Kset ಪ್ರಿಪ್ರೇಷನ್ ಎಲ್ಲ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗಳಲ್ಲೂ ಕೂಡ Kset ಅಕ್ಟೋಬರ್ 11, 2026 ಕಂಡಕ್ಟ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಬಟ್ ಅಫಿಷಿಯಲ್ ಆಗಿ KE ವೆಬ್ಸೈಟಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಅಪ್ಲೋಡ್ ಇಲ್ಲ. ಯಾವುದೇ ವೆಬ್ಸೈಟಲ್ಲಿ ಹೋಗಿ ಚೆಕ್ ಮಾಡಿದ್ರು ಕೂಡ ಇಲ್ಲ. ಸೊ ಬಟ್ ನಮಗೆ ಅಕ್ಟೋಬರ್ 11, 2026 ಅಂತ ಹೇಳ್ತಿರೋದ್ರಿಂದ ಇವಾಗ ತುಂಬ ಟೈಮ್ ಇದೆ ನಮಗೆ. ಸೊ ನಾವು ಪ್ರಿಪೇರ್ ಆಗ್ಬೋದು. ಸೊ ನನ್ನ ಹತ್ರ ಇರುವಂಥ ಬುಕ್ ಬಂದು ಈ CSIR NETR JRF ಬುಕ್. ದಿಸ್ ಈಸ್ ವೆರಿ ಗುಡ್ ಬುಕ್. ನಂಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ ಕೀ ಪಾಯಿಂಟ್ಸ್ನ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ, ಹಾಗೆ ಬೇಸಿಕ್ ಥಿಯರಿನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಇದು ನನ್ನ Kset Day1 ಸ್ಟಡಿ ಲಾಗ್ ವಿಡಿಯೋ ಡೈಲಿ ಅಪ್ಲೋಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತಿರ್ತೀನಿ. ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಫ್ರೆಂಡ್ಸ್, ಅನಾಲಿಸಿಸ್ ಫಾರ್ ದ CSIR NET ಪ್ರೀವಿಯಸ್ ಇಯರ್ಸ್ ಪೇಪರ್. ಸೊ ಯೂನಿಟ್ 1ಅಲ್ಲಿ ನಮಗೆ ರಿಯಲ್ ಅನಾಲಿಸಿಸ್ ಮತ್ತು ಲೀನಿಯರ್ ಆಲ್ಜಿಬ್ರಾ 56 ಮಾರ್ಕ್ಸ್ಗೆ ಕೇಳ್ತಾರೆ. ಸೊ ದಿಸ್ ಈಸ್ 2 highest ಸ್ಕೋರಿಂಗ್ ಚಾಪ್ಟರ್ ಫಾರ್ Kset ಆ್ಯಂಡ್ NET ಬೋತ್ ಸೇಮ್. ಆ್ಯಂಡ್ ಕಮ್ಮಿಂಗ್ ಫಾರ್ ದ ಪಾರ್ಟ್ ಸಿಯಲ್ಲಿ ನಮಗೆ 4.75 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳ್ತಾರೆ. ಬಟ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಇರೋದಿಲ್ಲ. ಸೊ ಈ ಪಾರ್ಟಲ್ಲಿ ನಾವು ಹೈಯೆಸ್ಟ್ ಸ್ಕೋರ್ ಮಾಡಿದ್ರೆ NETಲಿ ಈಸಿಯಾಗಿ ಕ್ರ್ಯಾಕ್ ಮಾಡ್ಬೋದು ಅಂತಲೇ ಹೇಳ್ಬೋದು. ಹಾಗೆ Ksetಗೆ ಕೂಡ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಬಂದು ಎಲಿಮೆಂಟರಿ ಸೆಟ್ ಥಿಯರಿ ಆ್ಯಂಡ್ ಕೌಂಟಬಿಲಿಟಿ. ರಿಯಲ್ ಅನಾಲಿಸಿಸ್ನ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಸೊ ಹಾಗೆ ಈ ಏನು ನಾವು ಬುಕ್ ಇದೆ ಅಂತ ನಾವು ಕೆಲವು ಸಲ ಏನು ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಕೀ ಪಾಯಿಂಟ್ಸ್ನ ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ಬಿಟ್ಬಿಡ್ತೀವಿ. ಬಟ್ ರಿವಿಷನಲ್ಲಿ ಕೀ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನೋದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಬೇರೆ ಬುಕ್ಕಲ್ಲಿ ಕೀ ಪಾಯಿಂಟ್ಸ್ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೆ ಅಂತ ಬೇರೆ ಬುಕ್ನ ತೊಗೊಂಡಿದ್ದೀನಿ. ಸೊ ರೀಡ್ ಮಾಡೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವೆ. ಫಂಕ್ಷನ್ ಆನ್ ಎ ಸೆಟ್. ಸೊ ಇವತ್ತು ನಾನು ಏನೇನು ಓದಿದೆ ಅನ್ನೋದನ್ನ ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ. ಹಾಗೆ ಕೀ ಪಾಯಿಂಟ್ಸ್ನ ಕೂಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಹೋಗ್ತಿರ್ತೀನಿ. ಸೊ ನಿಮ್ಗೆ ಇಷ್ಟ ಆಯಿತು ಅಂದರೆ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಬಂದು ಫಂಕ್ಷನ್ ಆನ್ ಎ ಸೆಟ್. ಸೊ ಈ ಫಂಕ್ಷನ್ ಆನ್ ಎ ಸೆಟ್ ಟಾಪಿಕಲ್ಲಿ, so what is that function on a set? We know that in a function two important thing is there. One is domain and codomain. So each and every element of a domain is corresponding to or mapping to the unique element of the B. Unique element of the B that is called a function on a set. That is important topic. And this function topic 3 types is there: 1 and 2 and 1 and 2. And 3 important formula is there. That 3 important formula important for your examination, especially Kset and NET examination. So first draw one domain set and codomain set. This is the function set. How to map this? Suppose draw 3 elements in the set A and 3 elements in the set B. Each and every element of a domain set mapping to a unique element on set B or domain B. So only unique element ಮಾತ್ರ ನಮಗೆ ಅಲ್ಲಿ ಮ್ಯಾಪಿಂಗ್ ಆಗಿರಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಎ ಫಂಕ್ಷನ್. ಇಟ್ಸ್ ಎ ಫಂಕ್ಷನ್. So what is the example for not a function? I will give that one also. Take one domain set 1, 2, 3 same element, and take another one codomain set A, B, C same, and function. So A, B. So each and every element of A corresponding or mapping to the unique element. But in this set one element mapping to or corresponding to the more than one element in codomain. So that's why it is not a function. It is not a function. So this is the best definition for a function. Each and every element of a set A is corresponding to a unique element of set B. So next one is classification of a function. 3 types is there: 1 and 2 and 1 and 2. So injection, surjection and bijection. So what is 1 function? No 2 element of a function. What is 1 function? No 2 element of a function corresponding to same element in the B. No 2 elements, only one elements corresponding to the codomain set. That is called a 1 and 2, and f of x1 equal to f of x2. What is on 2 function? Every element of a B as a pre-image of A. Every element of a B means codomain set have a pre-image of a domain set. Must and should. And 1 and 2 are bijective set means they satisfy both the condition of 1 and 2 function. Satisfy both the condition of 1 and 2 function. That is called a bijective function. So this is the points, and this is 3 important formula is there counting of a function. So how to find out the total number of a given function? How to find out the given number of a total function from A to B, from domain to codomain. Is determinant or cardinality of B to the power of cardinality of A. Cardinality of B to the power of cardinality of A. We know that what is cardinality. And second point is number of one function from A to B. So there are two condition is there, npm and 0. When npm, if n greater than or equal to m, if n less than m. And when it is 0, if n less than m. So what is npm? We know the permutation n factorial divided by n minus m factorial. This is the permutation formula. And last formula is number of onto function from domain set to codomain set. Number of onto function from A to B. This is also important formula. The condition is there, 1 less than or equal to m less than or equal to 1 less than or equal to n less than or equal to m. N power m minus summation I is equal to 1 to n minus 1 to the power of r plus 1 ncr m minus r m to the power of m. So what is that ncr? ncr means commutative the combination n factorial divided by r factorial into n minus r factorial. That is the formula for that. This is the important formula for counting of a function. If there exists bijective function, means 1 and onto function is called a similar set. Similar set is always denoted by A similar B. These all are important notes. Two finite set are similar. Then cardinality of the finite set, sets are equal to, two finite sets are similar, then cardinality of that sets also equal. Two finite sets are similar, then cardinality of the sets are equal. And every infinite set is equivalent at least any one of the proper subset of a proper every infinite set equivalent to, and every finite set never be equivalent to at least any one of that proper set. When one of the proper subset, every infinite set equivalent to at least one of the proper subset, but every finite set never be to. If every mapping from A to B is not a onto function, then B is more potential. When mapping from A to B is not onto function, then B is more potential than A. Countable infinite set is similar to a natural number. Countably infinite set is similar to a natural number. What is countable set? Either finite or countably infinite. And what is cardinality? We know that measure of a size of the given set or total number of element of a given set, also called cardinality. Cardinality of the natural number is always a leaf null, and cardinality of the real number is continuum. Continuum is always greater than a leaf null. So this is the cardinality. Cardinality means we easily find out finite set of the cardinality, but countably infinite set we can't measure. That's why natural number is unif null and real number is continuum, and continuum is always greater than unif null. So arithmetic of a cardinal numbers, we know that there are seven points is there. That all points is same related to exponential of the loss of exponent. We know that loss of exponents a power m into a power n equal to a to the power of m plus 1. When base is same, we add to the power. So a power m whole power n is equal to a power m n. And this also we know that when base is different but power is same, we multiply that base. A b whole power m is equal to a power n into b power n. then this both is different, but we have to read that alpha power n less than beta power n if alpha less than or equal to beta. And this one also same, equal to beta. This is the arithmetic of cardinal number. ಸೊ ನಿಮಗೆ ಲಾ ಆಫ್ ಎಕ್ಸ್ಪೋನೆಂಟ್ಸ್ ಈಸಿಯಾಗಿ ಗೊತ್ತಿದ್ರೆ ಇದನ್ನು ಕೂಡ ಈಸಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೋದು. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಪರ್ಟೀಸ್, ದೇರ್ ಈಸ್ ನೋ ಟ್ರಾನ್ಸ್ಫೈನೈಟ್ ನಂಬರ್ ಬಿಟ್ವೀನ್ ದ ಅನ್ಇಫ್ನಲ್ ಆ್ಯಂಡ್ ಕಾಂಟಿನಮ್. ಸೊ ವಾಟ್ ಈಸ್ ದಟ್ ಟ್ರಾನ್ಸ್ಫೈನೈಟ್ ನಂಬರ್? ಟ್ರಾನ್ಸ್ಫೈನೈಟ್ ನಂಬರ್ ಮೀನ್ಸ್ ಕೌಂಟೇಬಲ್ ಇನ್ಫೈನೈಟ್ ನಂಬರ್. The first transfinite number is unefinal. First transfinite number in between the unefinal continuum is unefinal. Unefinal is nothing but a cardinality of the natural number. No transfinite number in between the unefinal and continuum. We know that cardinality of the natural number is unefinal and cardinality of the real number is continuum. Continuum is always greater than unefinal. And see the next property, the set of all equivalent classes of the equivalent relation set is called a quotient set. Set of all equivalent classes of the equivalence relation set, that is called a quotient set. Quotient set of countable set is always countable. Countable set of countable set is always countable. Countable set of uncountable set may be countable or uncountable. These are the very important points. ಬಿಕಾಸ್ ಈ ಥರ ಪಾಯಿಂಟ್ಸಲ್ಲೇ ನಾವು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗೋದು. ಕೆಸೆಟಲ್ಲಿ ಆಗಿರ್ಬೋದು, NET ಎಕ್ಸಾಮ್ಸಲ್ಲಿ ಆಗಿರ್ಬೋದು. ಜಸ್ಟ್ ಫೋಕಸ್ ಆ್ಯಂಡ್ ಡೂ ರಿವಿಷನ್ ಪ್ರಾಪರ್ಲಿ. Quotient set of countable set is always countable, but quotient set of uncountable set may be countable or uncountable. Next, A is a similar subset of B and B is a similar subset of A, then A is always equivalent to B. Countable union of a countable set is always countable. B is uncountable set and A is A is uncountable but B is countable, then B minus A is uncountable. That is the important point I wrote once again. Set of all equivalent class of a equivalence relation is a quotient set, is called a quotient set, and quotient set is countable, then I wrote once again all the key points. Countable union of a countable set is always countable. Set is always countable, and B is uncountable and A is uncountable, then B minus E is uncountable. Suppose A is uncountable, B is countable, then A minus B also uncountable. These are all the important points what I am writing now. Finite Cartesian product of a countable set is always countable. Finite Cartesian, not infinite. Finite Cartesian product of the countable set is countable. Infinite Cartesian product of a countable set is uncountable. Set of all polynomial over countable set is countable. Set of all polynomial over countable set is countable. So next, algebraic number and transparent number. What is that algebraic number? Which one have a root of a polynomial x? So algebraic number ಅಲ್ಲಿ polynomial ಇರುತ್ತೆ. ಸೊ that polynomial ಅಲ್ಲಿ ನಮಗೆ ರೂಟ್ ಸಿಗುವಂಥದ್ದನ್ನ ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ನಂಬರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವುದು ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ಆಗಿಲ್ಲ ಅದನ್ನು ಟ್ರಾನ್ಸೆಂಡೆಂಟಲ್ ನಂಬರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎವ್ರಿ ರ್ಯಾಷನಲ್ ನಂಬರ್ ಇಸ್ ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಟ್ರಾನ್ಸಲ್ ನಂಬರ್ ಇಸ್ ಇರ್ರ್ಯಾಷನಲ್. ಸೊ ರ್ಯಾಷನಲ್ ನಂಬರ್ ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ಆಗಿರುತ್ತೆ, ಇರ್ರ್ಯಾಷನಲ್ ನಂಬರ್ ಟ್ರಾನ್ಸೆಂಡೆಂಟಲ್ ನಂಬರ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ನಂಬರ್ಸ್ ಕೌಂಟೇಬಲ್ ಆ್ಯಂಡ್ ಟ್ರಾನ್ಸೆಂಡೆಂಟಲ್ ನಂಬರ್ ಇಸ್ ಅನ್ಕೌಂಟೇಬಲ್. ಆ್ಯಂಡ್ ವಿ ನೋ ದಟ್ disjoint open interval also countable. Arbitrary collection of disjoint open interval is also countable, and non trivial interval, open interval a comma b is always uncountable. Real numbers also, all set of all real numbers is uncountable. So what is contour set? So contour set means is nothing but a closed interval, set of all number of closed interval, that is called a. And I wrote once again that contour set contain a number of interior points, no interior points. So this is the characteristics or properties of contour set. Contain no interior point, does not containing any open interval, containing only closed interval, set of all number of closed interval 0, 1. It is closed and bounded. It is closed and bounded. Perfect and uncountable. Perfect and uncountable. Measurement is 0. Measure is 0, or size of the contour set is always 0, and each point of a contour set is limit point. Each point of a contour is limit point. In this topic we close the elementary set theory and countability. So this is my first day 1 Kset preparations video. So suppose you have interested this video, suppose you like this video, please like me, subscribe and watch this video.